alarm tone and says, "Good morning, we're sorry to interrupt your program. Scientists have just discovered that the Earth's rotation has been fluctuating at an unusual rate. A group of specialists believe that the Earth is increasing its rotation with every second, and they don't know why." Even if the Earth increased its speed by 1 mile per hour, the day would only get shorter by a minute and a half or so. We wouldn't really feel it, and you could go on like nothing is happening. But as the Earth spins faster, our bodies, which are adjusted to a 24-hour timing, will have a hard time trying to cope with it. If you live by the equator, that means the rotation of the Earth is going quicker than at the North and South Pole. The area by the equator needs more time in order to complete its full rotation from the starting point. You'll experience more rain than usual. The Earth's rotation keeps the weather consistent and balanced so that nothing abnormal happens. But because the Earth is moving so fast, the weather is acting up. We'll start to see more storms and more cozy days inside, sipping on hot cocoa. Even though it seems weird, everyone can go about their day. But if the Earth picked up some speed and moved at 150 feet per second, the day would be reduced to only 22 hours. It kinda makes you feel jet-lagged 24/7. Every business works with the 24 hours a day schedule, so taking away even 2 hours can have catastrophic effects on the world economy. The whole calendar will have to change and adjust to the new timing. Clock designs will change with the new midnight, replaced with 10 o'clock. And with each week, the hours will shorten, so there will be no proper way of telling time except by sunsets and sunrises. The weather will continue to get worse and worse, feeling like the rain will never stop. The animals that rely on weather patterns won't know how to function, and mass migrations will occur from almost all species of animals. Flocks of birds will be flying everywhere and reach places they normally won't go to, affecting the whole food chain and ecology. Woods, jungles, and other places where animals roam are kept in proper balance when unaffected by humans. If it constantly rains in certain areas, then floods will force animals to move to other territories and compete with the predators in the area. If the Earth picked up speed every day, then standing on a scale in the Arctic would tell you weigh 180 pounds. But around the equator, you might weigh about 179 pounds. That's because of the extra force opposing gravity in that area. With the Earth spinning faster, all airlines around the world stop, since the radar systems have gone haywire and the weather is too dangerous to fly. Everyone has to get around by car. Satellites are positioned in such a way that it's crucial they remain where they are in order to bounce signals to us. Because of what's happening, Wi-Fi and TV signals can't go through. Communications around the world will end up short and slow, and eventually we'll have a total communication blackout. Ships will cease to operate and global trading will collapse, adding extra damage to the already failing world economy. Winds will get stronger and faster than usual, which means temperatures will change. Storms like hurricanes will be stronger than ever and have more energy for destruction. And still, at 100 miles per hour, the equator will now be swallowed up in the water. The Amazon basin and small islands will now completely submerge in water by around 50 feet. Most of the plant life will be endangered, especially by the equator. With woods threatened by floods, more animal environments will be in jeopardy. The trees and plants won't survive so much flooding. If the Earth rotated so fast that the hours would now be reduced to 15, then we'd probably feel like we're always on a jet plane going through turbulence. It would be impossible to sleep if the Earth kept picking up speed every second of the day. So days would be around 7 hours long as well as nights. The whole world would be flooded, except for the highest points and the tallest mountains. If that happens, humans will most likely end up there clinging to the last remaining clear patches of land. Most of the animal life will be extinct as well. And as the Earth is spinning faster and faster, the crust will lose its durability, allowing more frequent and stronger earthquakes to happen. Volcanoes will erupt all over, even if they're submerged in water. It'll go on like this for quite a while. Many major natural disasters like earthquakes, tsunamis, volcanoes, and even melting ice sheets have sped up the speed of the Earth by milliseconds. So, with the Earth's continuing speed increasing, these natural disasters will make the planet go even faster. Even if it's just for milliseconds, it's enough to have major consequences. The Earth is now spinning at 1,000 miles per hour, and as you're sitting with the rest of the survivors, you feel yourself levitating slightly. You'll see tiny pebbles and rocks floating inches from the ground. The clouds above you are passing like shooting stars. The air is thick with moisture, since water is rising to the top, forming thick clouds ready to pour. But since gravity is weaker, some of the rain is suspended in the air. Many small objects will be floating around as if you were in space. The days and nights won't be longer than a few hours. At this point, the whole world will be flooded, and the crust will be 80% gone. If it goes on any longer, there won't be any living things around, probably except for microscopic creatures that can withstand extreme and harsh conditions. The Earth would need to spin at approximately 17,600 miles per hour to cancel out the gravity for things to start floating around. At this point, all the water in the ocean will rise and look like reverse rain. The large mountain rocks will separate from the bedrock and levitate above the ground, looking like little planets in space. The Earth is now spinning 17 times faster than usual, which makes one full rotation around its axis only 84 minutes instead of 24 hours. If you manage to stay that long, then you'll literally see the days and nights go by in an instant. You'll also be floating aimlessly in the sky, bumping into rocks and other surfaces. You won't recognize anything anymore. The Earth's crust is ripping apart, exposing the magma underneath. So landing on the ground isn't an option. You'll see outer space as you go higher and higher. You won't know how fast you're going, but all you know is that you're probably the only human left in this spinning world. The Earth will eventually spin so fast that the rest of the layers will start to peel off, exposing the Earth's interior. It'll start to squeeze itself from the core until it becomes similar to a pancake. Nothing can survive at this point. So much heat will be produced from the core that the planet will heat up like a microwave. All the water will disappear, and it'll look like a red dot in the solar system. And once it starts to approach the speed of light, time will freeze. The rocks and floating elements won't move and will eventually be distorted. And with enough effort, the Earth will eventually turn into a black hole. Of course, nothing like this will ever happen. According to scientists, Earth will most likely slow down in rotation. Ever since the Moon came into the picture, the Earth has been slowing down by around 4 miles per hour every 10 million years or so. That's because of the Moon's gravitational pull on our little blue planet. It'll most likely go on that way.
You're sitting in the car, waiting for the traffic light to turn green. The temperature's so high today it seems the city is about to melt. You look at the traffic light and notice it's deforming. Drops are dripping down from it. You don't believe this is really happening, so you're rubbing your eyes with your palms and you find your silver ring is slowly flowing down your finger. You scream in fear because you expect the molten metal to scorch your skin, but nothing happens. The traffic light completely drains down. You want to press the gas pedal, but there's only some kind of liquid under your feet. The seat belt unfastens itself, and the car slowly sags. You open the door, and it falls off. You run out of the car and watch it slowly melt. The wheels, the blue body, the internal details, the motor, everything turns into liquid. Only the tires, plastic things, seats, car carpets, and glass remain intact. You hear screams behind you, and you see all the other cars around are melting. You want to record it on video, but your phone has become liquid too. You take out the remaining glass screen in the plastic case. All the metals around are melting. Street lamps and bus stops turn into a homogeneous mass. Suddenly, it gets completely silent. Car horns, the noise from the highway, sirens, exhaust fumes, and engine roars. All of it has disappeared. Rivers of liquid metal are flowing down the streets, and you're in the center of this. The metal stream carries away the tires and other car details. It knocks people down. Then, a low, loud noise sounds through the city. People are running out of malls, libraries, cafes, homes, business centers. Puddles form around all houses. Every building is equipped with metal structures, rebars, and fittings. Now it's all melting and seeping through the concrete. Metals are melting slowly, so people have time to evacuate from the city. All the buildings are collapsing and raising dust in the air. Sewerage hatchways are flowing downwards. The city's sewer system is melting. Water mixed with liquid metal comes out on the streets. People are swimming in this mass. They're using hundreds of thousands of rubber tires as life buoys. Someone's even riding a surfboard. Liquid coins are flowing out of your wallet. Hundreds of ATMs around the city are melting. Millions of paper banknotes are drowning in metal flows. All the gold reserves become liquid and paint the city with an orange color. Thousands of letters float on melting mailboxes. All data centers, computers, and servers become a part of the huge metal stream. Instantly, all the digital information in the world disappears. Televisions, game consoles, amusement theme parks are melting. Radio receivers, telephones, electrical wires, cables, and internet connections disappear. Millions of tons of metal fill in the street, then pour into rivers and oceans. The water is getting a dark silver shade. In one day, people lose all modern technologies and return to the Stone Age. Metal rivers flood cities. People run to the countryside. Bicycles, motorcycles, and other forms of transportation are gone. City residents are deprived of electricity and all things that are powered by electricity. It's not safe to be in a natural area either. Metals are hidden in the mountains and underground. Now they turn into liquid and cause deformation inside the soil and stone. Some mountains are ruined, like a melting hill of ice cream. Earthquakes shake the ground all over the world. Seismic activity wakes up volcanoes. They splash out a huge amount of lava and cover the sky with ash. Volcanic magma contains a lot of molten metals, but now they don't solidify. Pools of cold lava are formed around volcanoes. People learn to live anew in such conditions. They build houses out of plastic and wood, using ropes and glue to connect the materials. You can now easily start a fire with wood and stone. People burn glass to make it stronger. They make axes and other tools from high-strength glass and stone. But such items quickly deteriorate and break. You learn how to build dugouts. You drip the soil and use wooden boards to support the ceilings and walls. Almost the entire population of the planet lives underground, since it helps keep warm during winter. But it's not possible to live like this for a long time because of frequent earthquakes. Wooden chariots appear on the roads again. Problems with the harvest begin. Metals seep into the soil, and this disrupts the growth of the crops. Many people live near the ocean. During earthquakes, they get on wooden rafts or inflatable boats and sail away from the shore. To travel long distances, people fly in balloons. You can even get to a neighboring city if the wind doesn't take you away. It's impossible to send a letter to another country since there's no more railways. People make long walking journeys and live like nomads. You use pigeon mail to communicate with friends living in the neighboring city. It's difficult to get food and live in winter without electricity. But there is hope. Scientists can't find out the reason for the change of metals without technical equipment, but they put forward the theory that metals have changed at the molecular level. The molecules moved away from each other, and this caused melting. To bring everything back, you need to connect the metal molecules closer to each other, and people need an electric current for this. Fortunately, there's enough of it in the sky. Every day, lightning flashes somewhere. You just need to catch it. Scientists create plastic containers and fill them with liquid metal. All containers are connected by a rubber wire with molten copper inside. Copper is one of the best conductive metals. On a huge field, people place hundreds of such containers. Clouds are gathering. A strong storm begins. The lightning strikes the ground several times and finally hits the container. It comes through a copper wire and distributes the charge to all other tanks. A chain reaction begins. When the storm ends, people discover containers with solid metal. It worked! Now we have a couple of tons of ordinary metals. Scientists send mail pigeons to spread the news. Soon, people around the world are trying to catch the lightning. The resulting metals are enough to build minimal equipment for a power plant. Scientists use electricity from power plants to turn metals into powerful magnets. Liquid iron, copper, and aluminum seep deep into the ground and the ocean. To get them out of there, people build metal mining stations. First, they make a deep hole in the ground, then lower a huge magnet there. Liquid metals pass through the soil and stick to the magnet. People use the extracted materials to build new magnetic stations. They install them all over the world. Huge magnets appear in the seas, rivers, and oceans. People pump all the liquid metal out of the water and make it solid with an electric charge. Then, people create metal tools, axes, saws, machine tools, anvils, spokes, and wheels. Then, they make metal fittings and frames for houses. Life is slowly improving. People make chains, bicycles, and rebuild factories. They restore railways and launch the first trains. A new industrial era has come again. Iron, nickel, and aluminum are more expensive than gold because of a huge demand for them. Also, separating liquid copper from liquid silver and other metal separating operations is a difficult task. This increases the price too. When solid metals become abundant, their price begins to fall. Previously, to get iron, people dug deep quarries and mines where they extracted iron ore. Now, metals are liquid, and they attract themselves thanks to magnetic forces. You can stick a long magnet in the ground in your backyard, and the next day, it will be covered with iron. Easy metal mining accelerates technological growth. Now you don't need furnaces to melt steel or silver. You immediately get them in liquid form. You can pour metals into a jar and store them forever in liquid form. And an electric charge can make them solid. The first planes and ships appear. The international export and import of goods are fully restored. But the fastest thing people restored is power lines in the internet. In 1 century, humanity has managed to completely rebuild modern technologies.
The speed of light is the fastest thing in our universe. It travels across space, passing through Mercury and Venus to reach us, and it's slowing down. No need to panic though. The sun is getting weaker, but we won't see the effects of it for another billion years. In the vacuum of space, the speed of light is around 186,280 miles per second. Any slower than that, and humans would see the changes firsthand. There would be some awesome effects, like colors changing and the brightness of objects fading. We'd also notice some differences in everyday objects, their length and shape. Scientists created a simulation to see what would happen if the speed of light was slower. In a vacuum, the speed of light can't change. But if light passes through different materials and objects, it alters the way we perceive things. Light acts as a wave and a particle, meaning that it's a wavelength. The color and frequency are determined by the distance from crest to crest in the wave. It behaves similar to sound with the Doppler effect. Imagine you're standing in the middle of a busy highway and a honking car speeds through. Wow, that was loud. You can hear that whoosh-like sound of the horn because the moving object produces the sound while you're stationary. The frequency and pitch seem to change, but it's just the sound reaching your ear faster than it would if you and the car were both stationary. Light behaves similarly. The wavelengths change if the speed changes. Moving toward a light source and making the wavelength shorter will shift the color to a blue and violet hue. Moving away from the light source, and you'll get something more reddish. So if the speed of light slowed down to walking speed, we'd notice the colors changing when we approach an illuminated object. At the same time, the color would change around us and behind us. If you walk sideways, the colors you're walking toward would become bluer, and everything in the distance would become red. This information is useful to astronomers who are studying objects in space. If they're blue shifted, that means the object is moving towards us. And if it's red shifted, then it's going in the opposite direction. In fact, everything in the universe is redshifted, proving that the universe is expanding and getting further away from us. The slower it gets, the brighter it becomes. That's because the photons become more present for us to see. At this rate, we can see invisible light and increased intensity. You won't notice that effect much if you're standing still, but because of the Doppler effect, moving towards an object will have different colors and different light intensities. Another phenomenon we'd experience is time dilation. It's when you move at a similar speed as light and time decreases relative to someone who isn't. Space and time are relative. So if you're sitting at your desk wasting hours away, yeah, sounds familiar, doesn't it? All your movement will go through time and not through space. You're stationary, but you're still technically moving forward in time, slowly aging. The faster you move through space, the slower your movement through time will be. If you move at the same speed as light, then all your movement will be through space and not through time. To notice that, you'd need another person to watch you. You're not in a time machine. You're both on Earth experiencing the same time flow. To you, experiencing this firsthand makes it feel like you're going faster, because you're getting a lot more movement in space in a given time. The closer you get to the speed of light, the smaller you become. Well, not really, but it depends on who's watching. If you're the one traveling at such a speed, an object nearby will seem small, just as someone who's watching you travel at the speed of light will think that you're smaller than you actually are. The simulation that the MIT scientists conducted showed that if the speed of light drops, everything will become stretched out like a pancake. If you see mountains in the distance and then run at the speed of light, they will appear further away. Objects will become distorted, and it will feel like you're getting to a certain place faster because time has slowed down for you. If you're standing completely still and someone standing on your left-hand side throws a cube-shaped object over to your right-hand side, then naturally, you'll see one side of it unless it flips around. But in this new reality, you'll get to see the front side wrapping around the visible side you're seeing. If you're moving at the same speed as light in an infinite space, everything will be stretched out as you reach infinite speeds. In a world where people can walk at the same speed as light, we'll perceive nothing as normal. We'll have to get used to the way we see objects. Every movement we make will result in drastic shifts of colors. Even turning your head to look at something will feel weird. Let's say you're in a supermarket buying groceries, and you walk from aisle to aisle. The milk at the end of the counter will look like it's really close to you. But when you approach it, you'll start to feel like it's getting further away from you. The milk will also look a bit red. As soon as you get closer to it, it will shift to blue. If someone is passing through with a shopping cart, you'll see it as a sort of 3D model of a shopping cart. The color will shift as it gets further away from you. It will appear far away, but it's right in front of you. In fact, we don't really know the actual speed of light. Physicists gave it roughly 186,280 miles per second, but that constant is just for them to calculate other scientific stuff so we can understand it better. The problem is that we can only measure light with light beams and mirrors, but it's not like all we have to do is point a light beam at a mirror and measure its original path and its reflected path. Einstein's theory of relativity states that the original path of light moving from the source to the mirror may not be the same speed as the reflected light from the mirror back to the source. Hypothetically, if it takes light 10 seconds to travel from the source to the mirror and then back to the source, then we can conclude that each trip takes 5 seconds. But Einstein's theory is that it could take 9 seconds for light to travel from the source to the mirror and only 1 second from the mirror back to the source. Or vice versa. Or maybe completely different numbers altogether. That's why it's so difficult to measure light. A breakthrough came out for scientists when they managed to slow down the speed of light to 0 without losing its brightness. They did this by using ultra-cold atom clouds made with photonic crystals. These crystals are materials punctured with billions of tiny holes where light can refract. But what if we lived in a world where light stopped halfway? You'd wake up one morning and feel like it's twilight. You'd open the curtains and see that many car lights are on, but aren't so bright. You turn on the lights in your room, but feel like the bulb is tapping out. You replace it with another one, but it doesn't do the trick. You turn on the lights everywhere in your house, but it's all just giving weak light. You're confused and try to check if there's a problem with the electricity in your house, but it seems to be working well. You check on your neighbors, and they also have the same problems. Even experts in the field can't understand what's going on. Hours pass, and it's all the same. All the light in the world seems to have frozen halfway. Your phone is low on brightness, even though you bumped it up to maximum. Everything is getting darker. You learn from the news that it's a global problem. Light is slowly diminishing, and soon there won't be any of it in the world. You decide to wait it out while everyone else is panicking.